Hello everyone, my name is S.R. Manopantar. I am working as an assistant professor in the Department of Physics, Government First Grade College, Harihara, Davangere district. Today I am going to tell you about the interference of light. In this topic, we are going to discuss about interference, review of superposition of principle, coherent sources, condition for sustained interference. The phenomenon of redistribution of energy due to superposition of the light waves from the two coherent sources is called interference. Whenever two waves are superimposing with each other, there will be the modification in the intensity of the resultant wave. That modification in the resultant intensity leads to the redistribution of energy in the resultant wave. This phenomenon is called interference. There are two types, constructive interference and destructive interference. In the constructive interference, amplitude is maximum. In the destructive interference, amplitude is minimum. So later we will discuss this constructive and destructive interference in detail. Principle of superposition of the waves. This principle can be stated in two ways. First one is in terms of displacement, second one in terms of amplitude. Let us discuss first one in terms of displacement. This principle of superposition of waves states that when two or more waves are incident on the same point, the total displacement at that point is equal to the vector sum of the displacements of the individual waves. As we all know that wave equation is given by y is equal to a sine omega t, where y is the displacement, a is the amplitude of the wave. Let us consider two waves. Y1 is the displacement of the first wave, y2 is the displacement of the second wave. If these two waves, y1 and y2, are superimposing with each other, the resultant wave or the displacement of the resultant wave is given by y is equal to y1 plus y2, vector sum of the displacements of the individual waves. So that is what y1 plus y2, y is equal to y1 plus y2. So this is what the principle of the superposition of the waves. On the other hand, when two waves superimpose, the amplitude of the resultant wave is the vector sum of the individual amplitudes. A is the amplitude of the first wave, B is the amplitude of the second wave, then resultant amplitude is given by A plus B, vector sum of the individual amplitudes. So this is about the principle of the superposition of the waves. Here, if you see, when crest falls on the crest of another wave of the same frequency at the same point, then magnitude of the displacement is a sum of the individual magnitudes. This is called constructive interference. If the crest of one wave meets a trough of another wave, then magnitude of the displacements is equal to the difference in the individual magnitudes. This is known as destructive interference. Let me explain you by the diagram shown here. So this is the first wave and this is the second wave. And see here, this is the crest of the second wave, this is the crest of the first wave. Crest is falling on crest, trough is falling on trough. Here, what happens? Amplitude increases, or simply we can say amplitude will be maximum, because here in the definition we said that here amplitude is the sum of the individual magnitudes. So that is what amplitude will be maximum here. If you see here, this is the resultant wave, this is the resultant wave, amplitude is maximum. Similarly, coming to the second case, crest is falling on trough, trough is falling on crest. Here what happens, in the definition we said that it is the resultant displacement is equal to the difference in the individual magnitude. So what we have to do here, we have to subtract amplitudes. What happens here? Obviously amplitude decreases or amplitude is minimum. So ultimately our conclusion is, in the constructive interference amplitude is maximum, in the destructive interference amplitude is minimum. It means As we know that amplitude square of the amplitude is directly proportional to the intensity of the wave. Means amplitude increases, intensity increases. Amplitude decreases, intensity decreases. So ultimately, in the constructive interference, intensity is maximum. In the destructive interference, intensity is minimum. On the other hand, constructive interference occurs when the phase difference between the waves is a multiple of 2 pi. Destructive interference occurs when the difference is an odd multiple of pi. This is one more demo of the interference. I will tell you. See here, this is the wavelength lambda, and this is the crest. This is the crest of other wave. This is the resultant wave. Amplitude is maximum here. This is called constructive interference. Here also we have taken one more example. See here, this is the crest of first wave, trough of another wave. Crest is going to fall on the trough of the another wave. Here what happens, we have to take the difference of the amplitude, so amplitude is minimum. This is called destructive interference. So next point is coherent sources. Two waves are said to be coherent if they emit same frequency or same wavelength and are in phase or constant phase difference. Or in simple words, we can understand that if the two waves are having same frequency or wavelength and are in phase, that two waves are said to be coherent sources. Or there are two conditions for the coherent sources. First condition is both waves should have the same frequency or same wavelength. Second condition is both waves should be in the phase, or both waves should have the constant phase difference. That type of waves are called coherent sources. Then next question comes, how to get the coherent sources, or what are the conditions for obtaining the coherent sources. So there are three conditions. So first condition is coherent sources are obtained from a single source. So second condition is the source must emit monochromatic light. Third condition is the path difference between the light sources must be very small. These are the three conditions to get the or to obtain the coherent sources. See here, let me give you the concept of coherent sources. This is the sunlight. So my question is, sunlight is a coherent source? Obviously the answer is no, because sunlight consists of many different colors. As we know that different colors will not have the same frequency, right? The first condition tells us that for the coherent sources, first condition is both waves should have the same frequency. Here it fails. Different colors will not have the same frequency. So this is not the coherent source. So coming to the second case, this is LED, one color, that is monochromatic. So all three waves are having the same frequency. But see here, first condition is satisfied. See here, all waves are not in phase. So second condition fails. So this is also not coherent. Coming to the third case, laser, monochromatic, that is single color. So all three waves are having same frequency. First condition is satisfied. All three waves are in phase. See here, all three waves are in phase. Then two conditions are satisfied. Then this is called coherent sources. So I think you came to know that the concept of the coherent sources. So why can't two sources behave as a coherent sources? If you consider two separate sources, that sources cannot be considered as a coherent sources because they can never produce waves of same phase because each source of light contains infinite number of atoms and the waves which are emitted by them will not be in the phase. Therefore, we cannot consider two separate waves as a coherent sources. Yes. Sustained interference. The interference pattern in which dark and bright fringes positions are fixed on the screen is known as sustained interference. On the other hand, or in the simple manner, if the fringe width is fixed or the distance, the gap between fringes, dark and bright fringes is fixed or constant, that type of interference pattern is called sustained interference pattern. So what are the conditions for sustained interference? How to get this sustained interference? There are conditions. First condition is the sources must be monochromatic, means single colored. Second one is the two sources must be coherent. Third condition is the two waves must travel with the same velocity. After satisfying these three conditions only, we can get the sustained interference. Therefore, conditions for the sustained interference are the sources must be monochromatic, the two sources must be coherent, the two waves must travel with the same velocity. I hope you understood today's lecture. Thank you. Thanks for watching my video. Thank you very much.